Today, we are mastering the techniques required to solve simultaneous equations involving both linear and nonlinear systems. This topic is a cornerstone of the Cambridge IGCSE Additional Mathematics syllabus. You will learn to navigate complex algebraic structures, including products of variables and algebraic fractions. Understanding this is vital because it allows us to find where two graphs intersect, a skill frequently tested in the exams to separate A and A star candidates. When we face a system where one equation is linear and the other is nonlinear, the substitution method is our most effective tool. A linear equation, such as y minus x plus 3 equals 0, represents a straight line. A nonlinear equation, like x squared minus 3xy plus y squared plus 19 equals 0, represents a curve. To solve these, we follow a logical sequence. First, rearrange the linear equation to isolate one variable. Then, substitute this expression into the nonlinear equation. This reduces the problem to a single variable quadratic, which we can then solve using standard methods. Let us solve these simultaneous equations. Equation 1, y minus x plus 3 equals 0, and equation 2, x squared minus 3xy plus y squared plus 19 equals 0. We rearrange equation 1 to express y in terms of x. Y equals x minus 3. Now, we replace every y in the second equation with the quantity x minus 3. Expanding the terms carefully, we get x squared minus the quantity 3x squared minus 9x plus the expansion of the bracket x squared minus 6x plus 9 plus 19 equals 0. Simplifying further by removing the parentheses, we combine like terms to get negative x squared plus 3x plus 28 equals 0. Multiply by negative 1 to make the x squared term positive, giving us x squared minus 3x minus 28 equals 0. Factoring gives us the quantity x minus 7 times the quantity x plus 4 equals 0, so x equals 7 or x equals negative 4. Substitute these back into our linear expression, y equals x minus 3. If x is 7, y is 7 minus 3, which is 4. If x is negative 4, y is negative 4 minus 3, which is negative 7. Our solutions are the coordinate pairs, 7, 4, and negative 4, negative 7. Visually, these solutions represent the intersection points of the line and the curve on the coordinate plane. Visually, the solutions we just found represent the exact points where the line and the curve meet. The red line, y equals x minus 3, passes through the branches of the blue curve at two distinct points. Whenever we solve a system like this and obtain two real solutions, it means the line is a secant, cutting the curve twice. Notice that the algebra matches the geometry perfectly. The coordinates 7, 4, and negative 4, negative 7 are the intersections visible on the Cartesian plane. In some cases, your equations might involve products of variables, such as xy or xy squared. While substitution still works, we can often use division to eliminate one variable more efficiently. This is particularly useful when the terms are single products rather than sums. By dividing one equation by the other, we can cancel out common factors, leaving a simple equation for one variable. Let's solve the simultaneous equations. Equation 1, xy squared equals 4, and equation 2, xy equals 3. Step 1. Divide the equations. We divide equation 1 by equation 2. We write xy squared over xy equals 4 over 3. The x and 1y cancel out, leaving y equals 4 over 3. Step 2. Substitute back to find x. Now, use equation 2, xy equals 3. Replace y with 4 over 3. So, x times 4 over 3 equals 3. Multiply both sides by 3 over 4 to isolate x. This gives x equals 3 times 3 over 4, which simplifies to x equals 9 over 4. So x is 2.25 and y is approximately 1.33 to 2 decimal places. Sometimes, the nonlinear equation involves algebraic fractions. When you see equations containing fractions, your first priority is to clear the denominators. This transforms the equation into a polynomial form, which is much easier to manage. To clear denominators, multiply the entire equation by the lowest common multiple of all denominators. Once the fractions are gone, you can proceed with the standard substitution method we covered earlier. Let's look at an example. Solve x over y plus 2y over x equals 4, and y equals x minus 2. Step 1 is to eliminate fractions. Multiply equation 1 by the lowest common multiple, which is xy. Step 2. Substitute equation 2 into the result. Replace y with x minus 2. Step 3 is to expand and solve. X squared plus 2 times x squared minus 4x plus 4 equals 4x squared minus 8x. Expanding further, we get x squared plus 2x squared minus 8x plus 8 equals 4x squared minus 8x. Notice the minus 8x appears on both sides, so they cancel out. This simplifies to 3x squared plus 8 equals 4x squared. Subtracting 3x squared from both sides, we get x squared equals 8. So x equals plus or minus root 8, which is 2 root 2. Finally, step 4. Find the corresponding y values by substituting back into the linear equation. If x equals 2 root 2, y equals 2 root 2, y equals negative 2, y equals negative 2 root 2, minus 2. Let's look at a typical Cambridge-style question. Solve the simultaneous equations. 2x plus y equals 5 and x squared plus y squared equals 10. We start with equation 1. It is easiest to isolate y. Visually, we are looking for where the line and the circle intersect. Now, we substitute this expression for y into equation 2. Carefully expand the bracket. Remember that a minus b squared is a squared minus 2ab plus b squared. Combine the x squared terms. Subtract 10 from both sides to set the quadratic to 0. To make solving easier, divide the entire equation by 5. Factoring the quadratic gives x minus 3 times x minus 1 equals 0. This gives us two values for x. X equals 3 and x equals 1. Substitute these back into our rearranged linear equation, y equals 5 minus 2x. When x is 3, y equals 5 minus 2 times 3, which is 5 minus 6, resulting in negative 1. When x is 1, y equals 5 minus 2 times 1, which is 5 minus 2, resulting in 3. The final coordinates are 3, negative 1, and 1, 3. Always double-check by plugging these back into the original nonlinear equation to ensure they work. To secure an A star, you must avoid these frequent errors. A common error is expanding x minus 3 squared as x squared plus 9. Remember the middle term. It should be x squared minus 6 times plus 9. Always use the pattern a minus b squared equals a squared minus 2ab plus b squared. Students often find the values for x and stop. In a simultaneous equation, you must find the corresponding y values to complete the coordinate pairs. When substituting an expression like x minus 3 into a term like negative 3 by y, be very careful with the negative sign. Distribute the negative throughout the entire bracket. Negative 3x times x minus 3 becomes negative 3x squared plus 9x. When using the division method for products of variables, ensure the variable you are dividing by cannot be 0. In most IGCSE questions, the context or equation will imply non-zero values. Always rearrange the linear equation first. It is almost always easier to substitute a linear expression into a nonlinear one than vice versa. Use the discriminant. If a question asks how many points of intersection there are without asking for the points themselves, use d equals b squared minus 4ac on your resulting quadratic. D greater than 0 means 2 points, d equals 0 means the line is a tangent, and d less than 0 means no intersection. Check your answers. If time permits, plug your final xy pairs back into the original nonlinear equation. If the left side equals the right side, you know your answer is correct. It is time to test your understanding. Please pause the video now and attempt these 3 practice questions. The easy question. Solve y equals 2 times minus 1 and y equals x squared minus 4. The medium question. Solve x minus y equals 2 and x squared plus xy equals 20. And the hard question. Solve y over x plus x over y equals 2.5 and y minus x equals 2. Take your time with the algebra. Once you have finished, continue the video to see the full step-by-step solutions. Let us look at the easy question first. Since both equations are equal to y, we set them equal to each other. Rearrange into a quadratic equation, x squared minus 2 times minus 3 equals 0. Factorizing gives x minus 3 times x plus 1 equals 0. So x is 3 or negative 1. If x is 3, y is 2 times 3 minus 1, which is 5. If x is negative 1, y is 2 times negative 1 minus 1, which is negative 3. For the medium question, rearrange the linear equation to get x equals y plus 2. Substitute this into the second equation. Expanding, we get y squared plus 4y plus 4 plus y squared plus 2y equals 20. Collecting like terms, 2y squared plus 6y minus 16 equals 0. Dividing by 2 simplifies this to y squared plus 3y minus 8 equals 0. Using the quadratic formula, y equals negative 3 plus or minus the square root of 41 all over 2. Then find x by adding 2. For the hard question, clear denominators by multiplying by xy to get y squared plus x squared equals 2.5xy. Substitute y equals x plus 2 into the equation. Expand and simplify. We eventually reach x squared plus 2 times minus 8 equals 0. Factorizing gives x plus 4 times x minus 2 equals 0. If x is 2, y is 4. If x is negative 4, y is negative 2. The solutions are 2, 4, and negative 4, negative 2. To solve a system with a linear and a nonlinear equation, always rearrange the linear equation first to isolate one variable, then substitute it into the nonlinear equation. The number of real solutions to the resulting quadratic equation tells you the number of intersection points. 2 solutions indicate a secant line, 1 solution indicates a tangent line, and no real solutions mean there is no intersection. When dealing with products of variables or algebraic fractions, simplify the equations first by dividing or by multiplying through by the lowest common multiple to clear denominators. Precision is essential. Always expand brackets carefully, manage negative signs strictly, and remember to solve for both the x and y coordinates to provide a complete solution.